function notation.
So what was this blank?
That is probably the blank that I just did. Function notation. So that's one of the nice things about having the box, is that you'd be like, ooh, I was supposed to write something in there. What was it? So sometimes we have an equation that is also a function. Here's a relationship between x and y. Y is always equal to 3x minus 5. We could change this to a table of values. We could change this to an arrow diagram. We could change this to coordinates. Can someone tell me one coordinate that would be on that equation? So we've got an equation, and if you remember the other day, we said all these different ways that we could do a relation. An equation, a graph, coordinates, table of values. 2 and 1. Check it out. When x is 2, would you agree that this is true if y is 1? Plug in 2 for x. 6 times 2, no, whoop, 3 times 2 is 6, minus 5 is 1. So that would be one coordinate that makes it true. Could you find another coordinate that makes it true?
1 and negative 2.
1 and negative 2. Check it out. Yes, if you plug in 1, you get negative 2. Right? You could also make this into a table of values. The 2, 1 would show up like this, right? The 1 and negative 2 would show up like that. And if we're trying to figure, 0 and negative 5, that would be another one. Awesome. Is there going to be, how many points are there going to be? A lot of them, right? You could keep trying. Is there any point that you plug in for x that you get a different y value if you do it multiple times? Like, let's try 0 again. Plug on negative 5 again. Okay, let me wait for a bit. Okay, I'm going to try plugging in 0 again. It's still negative 5. Is there any x value that if we plug it in, we'll get a different y value from one time to the next? No. That makes it a function. No matter what you plug in for x, you will always get the same y value. Okay. So because it's a function, we are allowed to write it in function notation. Function notation says, instead of writing y, you write f bracket x bracket. In other words, the f bracket x bracket is just another way of writing y. Which you probably ask, why would I like to write 4 things instead of 1 thing? Well, this is called function notation. And the function notation lets you figure out certain things. So what you've already figured out is this. F of 2 equals 1. In function notation, the f of x is y, but it has the x involved. Can you see that this is the same as that? Where the x was, I have a 2, and I say it's equal to 1, and this whole thing is the y coordinate. The nice thing about function notation is the function notation allows you to be specific, like f of 2 is the y coordinate when x is 2. When I write f of 0, I'm saying, what is the y coordinate when x is 0? We figured that one out already as well, right? We plugged in 0 like a whole bunch of times. We keep getting minus 5. So this is called function notation. So the f represents the dependent variable, which is usually what we've done so far and called it y. Okay? And f depends on the independent variable x. And this is called function notation. So what we sometimes call the x values the input values, and the answer that we get, the y values, your output values. Sometimes I've even talked about or taught functions. Functions are kind of like machines. So here's the machine. You put an input number in there. We will call this machine g of x. So in functions, you can use f of x, g of x, l of x, k of x. F is the most popular one, probably because the word function starts with f. Okay? And then g is the second most popular because you used f already, so then the next letter is g. But I have a function g, and I'm not going to tell you what this machine does, but you're going to have to see if you can figure it out. So what you do is you put in input values. It goes into the machine does something, and something pops out. I'll start off with an easy machine. Here we go, g of x. Throw in a number. 2. 2. If you throw in 2, out would come a 4. So now you might have some ideas. Maybe times 2. Maybe what else could it be? Plus 2, right? Maybe it's squared. Maybe it's times by 5, subtract 6. Maybe it could be a whole bunch of complicated things. You probably can't tell
Put in another one.
until you put in another one.
3.
You want to put in 3? It makes a noise, of course. And
Square.
so you think you figured it out. The function was g of x is x squared. Any number you put in to the function, so this is sort of, if you think of it like a function like a machine, it really makes sense that you put a number into the function. What would come out? 25. Okay? And functions work that you can even put letters in. What would happen if I put in k? What would come k squared? We can get really, really abstract. What happens if you put a smiley face? You would get smiley face squared. Yes. No, that's really getting abstract, but the machine always squares whatever you put in. That's what the rule, when we write the equation, is like the rule of the machine. Okay? You want it? Okay. I'll make up a new one. I'll call this one, this machine, h of x. I'll have to come up with a, I'm going to come up with a new rule, see if you can figure it out. Okay. Go ahead, throw in a number. 7. You put in 7, out would come 16. Okay. 3. If you put in 3, I have to make sure I don't forget the rule. Otherwise, I won't be able to do it. Out would come 4. Put in 0. Oh, that is a good number to 0. Put in 0. -5. Whoa. Gage thinks he's found the rule. Or you think you found the rule? Okay, some people are going to, let's do one more number and then we'll say the rule. Let's go throw in a purple number. 2. What? 2? Oh.
Well,
Broken.
Is the rule broken? Right? You know how the rule could get broken really quickly? is if I make a mental math mistake, right?
Double check.
I think, well, let's double check. What rule do you think I was trying to do?
Minus 3 minus 5.
So 3x minus 5, that would be h of x. Does it work? Mm-hmm. Not a tough one. This one you got after 4. Let's do one. Oh, sorry, I shouldn't have this much fun. Here we go.
Why are you apologizing for having fun?
Because this is math class. I got one. See if you can get it. 2? Zero? One?
Times 3 plus 1? No, that's no.
I mean, it almost works. Works for 2 of them. Can throw more numbers.
4. Yeah. Three.
3? I did make a trickier one, didn't I? You think you've got the rule?
Is it x squared plus x plus 1?
Ooh, does it work? I don't know, that's his guess. So, tell me another number that you think would be a good one to check if that works. That would be easy mental math.
5.
5?
Yeah.
It works? Nice. And this is a function because if you plug in 5, your mental math will always give you 31. You'll never, well, you shouldn't get a different answer. Sometimes our mental math goes wrong and we get a different answer. But that's not because it's not a function, but just because we made a mistake. So a function is like a machine. You throw in an input value, you always get the same output value. And that's how we check. Each x value has only one y value. How does 1 get 3? What's 1 squared? 1 plus 1.
Plus 1.
2 plus 1.
Oh, 3.
Yeah.
Awesome. Okay, that's function notation. Function notation replaces the y with a function of x. And it's written that way so you're like thinking about the machine, you throw a number into the function, like I can do j of 10. That's pretty easy mental math. What would you get?
100.
Roman numeral 3. Perfect. 111. We read function notation by saying f of x. And I've said this already, but f is the most commonly used, then g, then h. But if you were figuring out an area of a rectangle and you wanted to make it a function, then often they would use a of x. Because they're like, ooh, area is a function of x, right? You used to just do area, a equals. You can now make it a of x equals if your equation had x's in it. So there are some examples of function notations with different letters. And then you've already, I kind of cheated and showed you this already, but you can evaluate functions. So they give you a function that this machine always does negative 3x minus 9. You can think of it like this. There's my machine of f of x. The rule is negative 3x plus 9. And this question is asking to evaluate f of negative 2. It's saying, well, if you threw in negative 2, what would come out?
15.
15. So we can draw it like that. Algebraically, what we can show is we can show f of negative 2 replaces the x with a negative 2. And it's equal to 15. So f of negative 2 is basically saying evaluate f or evaluate y if x is equal to negative 2. What would happen if I threw in a letter in this one?
Negative 3k plus 9.
Negative 3k plus 9. Basically, whatever you throw in, the rule is you multiply whatever you throw in by negative 3 and add 9. Here's some for you to try. Again, if you'd like, you can think of the machine.
Oh, we just did that.
Think of the machine of g of x. And you're throwing in minus 2, and you're throwing in 5. What are you going to get?
So what's the bar above it?
Yeah, what is the bar above it?
There's a box.
The box above it?
Oh, did I miss a box?
No.
Oh, the box above it was this box. F of negative 2 is the same as saying evaluate.
Oh, okay, yeah.
I can let you write that down. And you can start evaluating question 3 as well. We're good? So if you are showing your work, this is how you would show it neatly. You would say g of negative 2 means I replace the x with negative 2. In my equation, where I have an x, I put brackets, and I replace it with a negative 2. And now I do order of operations. Negative 2 squared, that would be positive 4. 3 times 4 is 12. 12 minus 1 is 11. You wouldn't need to show all of those steps. Probably your mental math skills are good, that some of you would probably be able to figure out that that's 11 right in your head.
Oh, you have to square negative 2 first.
You have to square the negative 2 first, right? Order of operations will always come into play. That's why when you do function notation, like when I do g of 5, when you replace a variable with a value, it's always good to put it in brackets so you can remember the order of operations. So this is going to be 3, 5 goes in brackets, it's getting squared, minus 1. I can't do 3 times 5 first, I have to square first. This will be 3 times 25 minus 1, 75 minus 1, 74.
Help me with the order of operations.
Yes, it's good reviews. Here, g of x, oh, this one, if I gave you this one as the function, I think you would have, that would take even longer than the x squared plus x plus 1. This one would have been really tough to figure out. But anyways, g of negative 1, that means wherever there's an x, it gets replaced by a negative 1. And again, we have to do our order of operations. So negative 1 squared will be positive 1. So this will become 3 minus a negative plus 1 plus 7.
It'd be 11.
It's 11.
Hi, so sorry to interrupt.
Hello.
Could you please send Brandon to the office for a moment?
Okay, he'll be right there.
Thank you.
Now we have fractions. Well, it's exactly the same idea. That gets replaced. Sorry, I'm smiling too much. I've got a function that I'm going to test on you guys after this to see if you can figure out the rule.
I don't get it.
So how do you multiply fractions? This is 2 over 1. Right? Multiplying fractions mean multiply the tops, multiply the bottoms. Maybe you know that 2 divided by 2 simplifies to just 1. So this is going to equal 3 minus 1, which is just 2. And I think I might not have given myself enough room for C. Luckily, I can cheat. Not going to be enough room. If I wanted to do g of 1 minus h of 2, it would equal, well, g of 1, I'm going to color code this for you guys just to help you see it even better. I'm going to put the subtract sign in green and h of 2 in blue so you can follow along as we're going. Okay? Now, g of 1 would be plugging in a 1 into g of x.
Would it just be the same thing as
It won't be the same thing because the 1 squared is exactly the same, but the minus 1 is going to be slightly different. Okay? Then I have a subtract sign. That's where my green subtract sign would still go, right? And then I'm going to make a tiny mistake that I'm going to fix in a second, but I want you to watch to see if you can see the tiny mistake. Now I'm going to switch to blue because I want to do h of 2. H says, and I made a tiny mistake. You think you see it?
Wouldn't you put the new one in brackets? Because
There's the tiny mistake. Because in the original equation, you're subtracting all of h of 2. Okay? Not just the first part of it. So I need to put in brackets. Sometimes you could have also put the black one in brackets if you like to hold it together temporarily. but there's nothing in front of the black one, so the brackets aren't necessary. However, it's not bad, and that's why I wanted to color code it, to think of, okay, I could evaluate g of 1 all by itself. It's going to be 3 plus 7 minus 1, it's going to be none. Subtract, and then I could have calculated h of 2 on its own. It's going to be 3. My final answer is whew.
No one heard that.
Oh, I was on mute.
Oh, thank you.
Okay, so, sorry, I was on mute. So just a quick recap, we did the black on its own, we made sure that we had the brackets, then we had to do 9 minus 3, which Violet said was 3, and we got 6.
Wow.
That's wonderful. You're gonna look this video up when you're 25 and go, oh yeah, I remember that. Okay, not bad. Okay, this is function notation. And if you like to think of those machines, we had g of x as the black machine and h of x as the blue one. We plugged in 1 in the black one and out came a 9. We plugged a 2 into the blue machine and out came a 3. And you wanted to subtract those two, so we got 9 minus 3.
How do you tell that you're on mute?
There's a little red light on. So if you ever see that red light on, okay, then I'm on mute. Right now, no one it's not recording my voice.
Sometimes when I watch the videos, there's just like so much silence, and I'm like, what is happening?
Yeah, it might have accidentally, like if I hit the mute, so if you see the mute button on,
Okay, you're on mute.
I'm on mute, it's not recording anything right now. It's just a blank screen and you're like, what's happening when you're watching the video? Okay? Sometimes I put it on mute if I want to make fun of the principal or something like that. Then I want to make sure that that's not on.
Oh, you're not on mute.
He's right there.
Sometimes if I'm really careful, I make sure I shut the door first.
Okay, you're on mute.
Okay, so now we're back.
Now we're making fun of the principal.
All right, is this a function?
Yeah.
Right? You don't have the same x value, hit 2 different y values. Each x value has 1 y value. Makes it a function. Identify independent and dependent. Independent is the number of tickets, and dependent is the cost. Right, so this unit has lots of little definitions that we've had, like rangy and domains and independent and dependent. So we just have to make sure that we pay lots of attention to those when we talk about them. And just ask yourself, how are you going to remember those things? One thing that's always easy to remember is the second one depends on the first one. Okay? How much is it going to cost? Well, it depends on how many tickets you buy. Okay? Give the domain and range. What are our x values? 1, 2, 3, 4, 5. What are our y values? Oh my goodness, why did I have to include so many decimals?
Oh, you make these?
Take the notes?
Yeah.
I mean, some questions I get from different places, but could you make this into an equation? My function here, I would probably do c of x. What's the equation? What would be, again, here's your function. You put in 1, out came $1.75. You put in 2, out came $3.50. What's the rule?
Times 175.
You just times whatever you put in by 1.75, right? So if you put in x, out would come 1.75x. That is your function notation for this equation. Okay? And then it opens up different kind of questions. Like if you have this, do you think it's possible to sell 6 tickets? We didn't include that in our domain, right? But sometimes if you're given an equation, maybe the table of values is just the beginning. So then we might say, well, actually the domain of this one is it all numbers? Could you sell 10 tickets? Could you sell -3 tickets? No. So it's not all numbers. Could you sell 2.75 tickets?
No.
No. So what numbers, if yeah, the whole numbers. Could you sell 0 tickets?
Yeah.
Yeah, you could sell 0 tickets,
You sell a lot of zero tickets.
right? So this makes us think about the domain in a different way. So if it's the whole numbers, are you ready for some weird notation? What did we use for the whole numbers? What symbol did we use for the whole numbers?
It was like
W with the double line?
Yeah, W and double.
That would be how you'd write the domain for that one, if you include all the whole numbers. We learned those symbols in our radicals arena. Remember, integers was this one?
No, I don't.
Real numbers was this one? Rational numbers was that one? Irrational numbers,
Line.
the line over top?
No.
We are going to use this one the most. This one second most. We'll use those symbols over and over again. Because sometimes the domain is always possible. For example, right? Oh, I was going to give you a function and see if you could figure it out. There we go. Tricky one. Here's the machine. Throw in a number. 2. Out comes a 2. 3. Out comes a 3.
0.
0.
-2.
Out comes 0. -2. Out comes -2.
Times by 1.
It's just nothing, there's nothing.
It just keeps it the same? No. It does something. But so far you haven't figured it out. It's not times by 1.
It could be.
It could be. So far that would work for all these. What else could you check?
Oh, letters. K.
Hmm.
Put in a K.
I can't really. The best I can do for K is do that.
Okay.
Yeah, but you don't know what that means, so it doesn't really help you.
What does it mean?
10.
I think it's, or maybe it's, yeah, like that. Or maybe it's only on one side. I can't remember the exact notation. 10 will come out 10. Try numbers you haven't tried.
Oh,
1.5. 1.5
Oh.
comes out 1.
Oh.
Here's
2.
Yeah.
Yeah, rounding, that would be 2. So this isn't the rounding function. That would have been a good guess. If it went to 2, then you probably would have guessed right it's the rounding function.
Oh, it gets rid of all decimals.
Oh. So try something else that you would check that.
Okay,
3.3.
3.2. 3.7. So it gets rid of all decimals.
Gets rid of all decimals. Give me a negative number.
Negative 1.
1.
0.5. Round down.
It rounds down. This function rounds down. It's called the floor function, where it takes away and goes down. Okay. There we go. Sorry. That one made me think. Right? Sometimes when we test things, we get stuck on whole numbers. In fact, you get stuck on whole numbers, then someone thinks, oh, I should try 0. That's good. And then like, ooh, maybe I should try a negative number. Because I could have picked the absolute value function, which changes any negative number to positive, but keeps positive numbers the same. That would have been one. That would have been interesting as well. Oh wait, sorry, getting carried away with machines. We're still back at this. What would C of 100 mean in words? This is the same question as before.
It would mean cost of 100 tickets.
Perfect. And this is why mathematicians like function notation. Mathematicians do not like writing lots of words. They don't want to say, what is the cost of 100 tickets? The wrist will get sore from writing 7 words. So they just say, oh, C of 100. Much quicker way of asking the same thing. Okay? This is also what makes math hard. Because mathematicians like to make things simplified so they don't have to write a lot, but then they don't tell you a lot and ask you to solve it. And that happens on your quizzes. You say to me, what does this mean? And when I explain it all in words, you're like, I'm able to do that. But when I just say, find C of 100, you're like, well, find the cost of 100 tickets. Why didn't you say so? Well, mathematicians are saying, pay attention to what things mean, because we're going to ask you things, but not use a lot of words. Calculate C of 100. Right? We know that C of x was equal to 1.75x. That was our formula. So C of 100 would replace the x with 100. And I like that you just were able to do that in your head and get 175. What does this one mean?
N equals 5,000.
C of n equals 5,000. What does this mean? What is the number that we put in stand for? C of 100, you said that was 100 tickets. What's after this? The total cost of n tickets is 5,000. Does that make sense from that notation? Because they tell you what the y, C of n, that's your y value. They tell you your y value is 5,000. So you know, as an ordered pair, you would know this is 5,000. This is what you don't know.
Can I go watch it? I was gonna ask.
Is it 10 tickets? You have to wait till she gets back, she'll hurry.
Yeah, hurry. Just have to up.
The cost of N tickets is 5,000.
What if it's
It's gonna be more than 100, right? So the 100 only costs 175. What about 1,000 tickets? No, 1,000 tickets cost too much. 500? How would we figure this out? We know that C of N
But
is
it the 1.75
5,000.
thing still?
Don't we just divide 5,000 by
Check this out.
1.75?
Yeah, do we?
Here's your function. What would happen if you threw in an N? What would come out?
5,000. No.
Right, 5,000. What else would come out if you didn't know this?
C.
Here's your C of X. We've got a formula for it. You plug in, if you throw in 1, you get 1.75. If you throw in 2, you got 350. You would get, yes, 1.75 N. So what do we know here? We know that 1.75 N is equal to 5,000. And you have algebra skills. You should be able to figure out with your calculator, with algebra, how do I find out what N is? What would you have to do to this equation to get the N by itself?
5
Right, the opposite of multiplying by 1.75 is dividing by 1.75. Take out our calculators. 5,000 divide by 1.75. Oh! What does that tell us? Can you sell 2,857.14 tickets? No. If you sold 2,857, you'd be very close to $5,000. Be 25 cents short. So you could get this question by saying that the theater production needs to make at least $5,000 to pay for all their expenses, especially Gage's outfit that was really fancy. That cost a lot of money in its production. Okay, so they need to make at least $5,000. How many tickets do they need to sell to make sure that they don't have to, like,
2,868.
yes, they'd have to sell at least 2,858 tickets to make some money. And then everything after that would be profit. So these are things that companies have to decide. How much money how much are we going to sell our tickets for? How much are we going to spend before we get to the program? And how much tickets do we need to sell to make sure that we're making money? Because I need to pay Gage, I need to pay Ben, right? Ben is a more expensive actor than Gage, sorry. We just put you in a fancy outfit there to sort of make up for other. Oh, and I'm still recording. So this is how function notation helps us understand these questions and figure them out.
No more questions.
No more, we have one more question.
But the bell's gonna ring.
The bell's gonna ring in 10 minutes because it's
Yeah.
later than you think on late start.
Keep it real. In 8 minutes.
No, it rings at 12:05.
We should like, yeah, so it's actually 12
It's
minutes.
late start, so we get
Well,
to
that's
add
a little,
2
hang
minutes.
on, hold on.
We should do lots of questions.
Yeah, 12 minutes.
And
Rings at 12:07. 12:05.
So sometimes you get equations, like in science or something like this, you often get equations like this, and we use letters that represent the thing that that things stand for. So volume is a function of distance traveled. So we've got this equation. If we want wanted to write this in function notation, nothing would change on the right-hand side. We would just have to write the left-hand side as function notation.
So you just have to do 50 divided by, oh no, wait, yeah, 50 divided by 0.08, and then take that number and then make it a negative.
What's your independent? Always what your x would be. And what your y is always, so this is independent, this is dependent. Independent is the distance. You are in control of that. The volume of gas depends on how much you've driven. What does this mean? V600.
Sorry, what about 8?
V600 is asking, what is the volume of gas in liters after you've traveled 600 kilometers? Negative 0.08. Plug in 600 plus 50. Alright. Go to my calculator. 0.08 times 600. I get negative 48. Plus 50. 2. What does this mean? You would have 2 liters of gas left in your gas tank. That's almost empty. Right? Probably the little light would come on saying, you should fill up with gas. How big is this gas tank? Can you see how the equation tells us how big the gas tank is? If it was completely empty and you went to fill it up, how many liters could you fit in it? 50. How do you figure that out? Well, if it was completely empty, right, or you haven't driven any kilometers, would mean that it's completely full. That would be when D is 0. Plugging in 0 for D, that's really easy mental math to figure out that this car can hold 50 liters. These are the ones I find that students have the most trouble with. This V of D equals 26. Again, if you think about the machine and you plugged in D, you would actually get the formula. Negative 0.08 D plus 50. But now we know that it's equal to 26. They're basically saying, you know that the y coordinate's 26. What D value does that? So you don't know in the formula, you know the volume is 26, but you don't know the D value that gets you that. And we have to do the mathematics, combine our like terms. Are there any like terms in this question?
Yeah, 50 and 26.
Yeah, 50 and 26, but they're on either side of the equation. In order to combine them,
So minus
they would
50
have to be on both sides. So it makes sense to minus 50 on this side and minus 50 on this side. That gives me negative 24 equals negative 0.08 D. I want to get the D by itself. How do I get rid of the negative 0.08? Right? The opposite would be dividing. That gets D all by itself. Go to my calculator. Negative 24 divided by negative 0.08, 300. Is equal to D. Does this seem like a good spot to stop?
Yeah, great spot.
Yes, there's homework questions there.
You were muted the whole time.
Oh, I should. See the games today? I know. I couldn't believe it. No.